Hi everyone, in today's lesson we're going to talk about the normal curve day 3. Today's goals will be to use the calculator to estimate the percentages of the area under the curve, and we will use those percentages to estimate information based off the population. So let's read through example number 1 together. It says, assume that the ages of the first year college students are normally distributed with a mean of 19 years and a standard deviation of 1. The first part is saying, to the nearest integer, find the percentage of first-year college students who are between the ages of 18 and 20 years old inclusive. So before I answer the question, I'd like to set up my picture. So the picture here is key. I cannot stress enough how important that picture is. So we're going to first put our mean in the middle. So the mean is 19, and the standard deviation of 1 means that every tick mark I'm going to add 1. So I should have 20, 21, 22, and subtract 1, 18, 17, and 16. So the question is asking how many students, or find the percentage of students that are between 18 and 20. So I want from this tick mark to this tick mark, and I want to find the area under this curve. So if you write the z-scores underneath, a mean has a z-score of 0, 1, 2, and 3. -1, -2, and -3. So I want the area under the curve between a z-score of -1 and a z-score of +1. So technically, if you remember from yesterday, I talked about the area under the curve between one standard deviation, and that answer is about 68. Now, you can memorize that, right? And say, okay, I know the definition, that's the answer. But what if I gave you, a z-score of 18.5 and 20.5? It's not going to be exact. So we have to find a formula that will work every single time. And we're going to use the calculator to do so. So you're going to hit a couple buttons. The first thing you want to do is hit second. And then you want to hit the VARS button, V-A-R-S. And it's located next to the clear. And then you want to select option 2, which says normal CDF. So when you do that, you should get something that looks like this. You should see your screen that says lower, upper, mu, and sigma. And you should have a number in the lower, but you're going to clear everything out. The only thing you're leaving is the 0 and the 1. Remember, the 0 is the mean, and the sigma is the standard deviation. So if this helps, you could write mean, and I'm going to put SD for standard deviation. That's the mean and standard deviation. And if you notice, the mean is always 0 and the standard deviation is 1. That is basically saying I'm using a mean of 0 and a standard deviation of 1, so I'm always going to use z-scores. So into this lower and upper, it's very important that you only put in z-scores. So I'm going to put over here z-scores. Okay, it's very important that you do that. So I'm asking between the ages of 18 and 20. They represent a z-score of -1 and +1. So when I put in my lower, I'm putting the smaller z-score, which is -1. And in my upper, I'm putting a +1. So I'd like you to take a minute, type those into the calculator, and then there's a button on the bottom that says paste. So when you're done, hit paste, and then hit enter. And you should get 0.6826. Right? So hit paste and then hit enter. All right? So 0.6826. If I ask to find the nearest percentage, I'm going to move the decimal 2 places to the right, and that gives us about 68%, which matches up exactly what we needed to find before. Okay, so the second part of the question says, if there are approximately 10,000 students enrolled at a local college, how many of them are between the ages of 18 and 20? So I want to find, of this 10,000, how many of them are between these ages. So all we have to do is take the original amount of students, which is 10,000, and multiply it by the decimal equivalent of 68%, which is 0.6826. So take a minute, pause the video, and type that in and hit resume when you're ready for the answer. Okay, so you should have gotten approximately 6,826. And that's how many students out of the 10,000 that will be between the ages of 18 and 20. Okay, let's try another example. So example number 2 here says, the heights of women in the United States are normally distributed with a mean of 64 and a standard deviation of 4 inches. So before I do anything, I'm going to set up my picture. My mean is 64, so that goes in the middle, and my standard deviation is 4. So that means for every 1 standard deviation, I'm going to add 4. So every tick mark. So I'm adding 4 to this, I get 68. I add 4, I get 72. I add 4, and I get 76. And then subtract 4. So 60, 56, subtract 4 again, and 52. And I'm going to go ahead and put my z-scores below, 0, 1, 2, and 3, -1, -2, and -3. So again, everything here in red are my z-scores. And the question is saying, calculate the percentage of women who are between 57 and 70 inches tall. So 57 is about here, and 70 is about here. So I want to find the area under the curve, which represents the percentage between 57 and 70. But the problem that you should be noticing is that 57 is not the z-score of -2, it's not exactly, and 70 is in between 68 and 72. So in order to use the calculator to find this answer, and remember we have our lower, our upper, our mean, and our standard deviation. So remember, the mean and standard deviation never changes. This 0 and 1 will always stay there, and the lower and the upper have to be put in as z-scores. So these two need to be z-scores, and these two never change. So we're going to have to use the information that we did last time to find these z-scores. So the z-score formula is the data value minus the mean over the standard deviation. And the 57 and the 70 are my data values. So I need to do 2 formulas. So the data value of 57 minus the mean of 64 over the standard deviation of 4. So take a couple seconds, pause the video, type that into the calculator, and hit resume when you're ready for the answer. Okay, so I got -1.75. Now we do a z-score for the other data value. The other data value here is 70. So 70 minus 64, which is your mean, over my standard deviation of 4. So take a minute, type that into the calculator, and hit resume when you're ready for the answer. And you should get about 1.5. So these are now my lowers and my uppers. So 57 is going to be a -1.75 for my z-score, and my upper is 1.5. So to get this calculator screen, this lower and upper, what we're going to have to type in is we're going to have to hit second vars. And remember, the vars is right next to the clear. And we're going to hit option 2, normal CDF, which is option 2. And then take a minute, type in all of the information, and then hit resume when you're ready for the answer. Don't forget to hit paste as well as enter. So your final answer should be 0.89313 ... So I want to the nearest whole percent, so I need to move the decimal 2 places to the right, and I got 89%. All right, last but not least says, if there are approximately 166 million women in the United States, how many of them would be between 57 and 70 inches tall? So remember, to write out the number 166 million, we need 6 zeros. and we want to multiply this by the decimal equivalent of 89%. So the more decimal places you use, the better, the more accurate. So I'm just going to use those. So take a minute, pause the video, and then hit resume when you're ready for the answer. Okay, so I got approximately 148,259,580. And that will be the amount of people out of the 166 million that would be between 57 and 70 inches tall. Okay, I'd like you to actually try this one on your own. So take a minute, jot down the problem, and then hit resume when you're ready for the answer. Okay, here's the answer. So a couple things that I want to point out is that you had to first change the 410 and the 590 to z-scores. So the 410, if I use my data value of 410, my z-score was negative 225. If I use 590, my z-score was positive 225. So your lower is the negative, the upper is the positive, the mean and the standard deviation stay 0 and 1, and this was the decimal that I got, moved it 2 places to the right, and I got 98%. The second part says approximately 500 students took the exam, so how many of them would get the 410 to 590? So we multiply the 500 by the decimal, and I got 487.75. Now, a lot of people are probably wondering, well, I can't have 0.75 of a person, so you would round down to 487. But for the purposes of this assignment, I'm really not worried too much about that. So you can just round the numbers like normal. That 487.75 would round up to 488. It's approximate. It doesn't have to be exact. So round like normal, even when you're talking about people. All right, so that's it. That's the final answer. If you have any questions, please let us know.